Okay, good morning, dear Diego and all of South America. Good afternoon, dear project partners and all of Europe. Welcome to our first webinar for the Erasmus Plus project 3D STEAM with the title Accelerating STEAM-related knowledge and skills via 3D modeling and 3D printing. Our speaker today is Diego Lieban. He is a professor at the Instituto Federal do Rio Grande do Sul in Bento Gonçalves, Brazil, and a collaborator of the Scientific Initiation Program for Student Awards in Mathematics of the Brazilian Olympiad of Public Schools. He graduated in 2002 from the Universidade Federal do Rio Grande do Sul with a degree in mathematics teaching and completed his master's in mathematics in 2010 from the same institution, where he also worked as a tutor in a distance specialization course, Math, Digital Media and Didactics. He completed his PhD in STEM education in 2019 at Johannes Kepler Universität in Linz, Austria, where he conducted part of his work and studies to implement the 3D printing features on the GeoGebra platform. He was a volunteer teacher in a primary and secondary school in Canada in 2017, working with STEM projects. In 2015, he participated in the international program VET, Teachers for the Future in Finland, focusing on technological development and innovation in education. His areas of interest are mathematics teachers training and the use of educational technologies. Let's welcome Diego with his presentation entitled Connecting Physical and Digital Worlds, Makerspaces, Games, and Teacher Innovations.
So, hello everyone. Thank you for the introduction, Yves. Again, one more thanks for the invitation for Yves and all other colleagues who are involved in this. It's a pleasure to be here with you and share a little bit of my work. Just to keep the engagement in this movement with 3D printing and maker spaces. So today I'm talking a little bit about connecting physical and digital worlds, and try to share what I'm doing in my school or institution since I came back from my PhD studies in Austria. So basically, I'm really deeply involved in a makerspace lab, which calls PIPA, if makers. PIPA is an acronym here in Brazil. It works as a research, innovation, learning, and prototyping. Sorry. But also means this kind of wine tanks in Brazil. It calls pipa because here in my work town is a wine production city. So that's the reason of the name. But also I'm collaborating with JKU and GeoGebra developers who are working in JKU University. So first of all, I'd like to share with you. I hope you can see my screen. Not yet. I'm sharing now. Okay. I think it's coming. Good. Great. So here in the bottom, you can see the logos of my institution and the laboratory, and also from JKU and GeoGebra. So I'd like to introduce you to my space here in Brazil, the maker space where we are developing most of the materials I'm sharing today, and you can get a little bit of the feeling how students are involved here in developing their ideas, but also something really important for us is how they share their developments and ideas with the other ones. So we are receiving little every single week uh, dozens or centens of students who are coming for the local region to visit us, and then we are spreading out part of our intention here. So there are some visiting here to share some materials with 3D printing or laser cutting. You can see there is a screen on the wall over there, but also sometimes they are teaching uh, young students for robotics, for example. So we have different branch, let's say, to spread the ideas. Here on the left side, in these pictures on the top, uh, I hope you can see the mouse indicator here. There are some 3D printing, 3D printers, and in the back of this room there is a laser cutting machine. So let's continue then. Please, if you have any questions, you can interrupt me anytime. Basically, today I'm talking a little bit about physical and digital connections in four different directions. So, as 3D printing, laser cutting, augmented reality, AR, and also the use of Arduinos for robotics programming and other materials which are connected with. But actually, the four dimensions or directions that I'm considering even more are more conceptual, I would say. They are the creativity, critical thinking, communication, and collaboration. Uh, these dimensions are mentioned by Yuval Harari as uh, the important skills that we have developed in the schools for the 21st century, especially in education. So, from my point of view, when we are working with this kind of labs and opportunities, we have conditions to explore these four C's, which are really significant in education. So, also, here I'm considering STEAM as a creative practice by using physical and digital resource combined. STEAM, I assume everybody who is here knows a bit. It's an acronym to put together the science, technology, engineering, art, and mathematics. So basically, what we are considering is how to use mathematics. I'm a math teacher, so how to use mathematics as an end, not as an end, but as a mean to get some results, either in arts or physics or biology in different areas. So here I brought some examples in arts, for example, something that we can print out. It calls True Shit. It's a really nice puzzle, let's say, or something in chemistry, some molecules, the methanol molecules, some cubes as a puzzle as well. Biology, something that we can print out, and for sure we have to use a lot of math if we are working with measuring or scale, something like that. Physics, this Newton pendulum or experiment, And also even in math, here we have the integral principle. Okay, and more important for our point of view is all of this kind of learning is developed by the students. In fact, when they have to build uh, whatever they have to do or they want to do, they can learn by this process. So here I'm sharing some examples, for example, of a solution of one of the problems that I'm sharing with them. They had to develop a dissected cube. I'm explaining soon. And the other one, they had to create a lamp in an artistic way. So I share the name of the students who made this. Just to explain a little bit about this project, the Cube project, and we develop here some or whatever I have tried out in different parts of the world, in Linz, in Israel, in Canada. Um, this task where they have to find a solution to split or to dissect a cube into equal parts, either in volume or surface area. This is not so trivial, but based on previous example, they can create their own. So we are pushing them in a way to develop their creativity as well as their mathematical reasoning. Another strategy that I have used with my regular students, by the way, something important to say, I'm teaching for high school level, but also for future teachers, students here in Brazil in my institution. So, and I like both equally. Um, so here is a kind of task that I have developed with my for my students, where they have to recreate a logo or any draw they want to do based on only circles and segments or arcs of circles. So basically, it's a technique used for the anxious logo of Twitter logo. So they were using only circles to create this, and basically in this idea, they created their own uh, animals or logos. There is a book with these solutions. So if anyone is interested in explore it, I can share lately um, this presentation so you can assess this book. But the idea is converting this logo or animals they have created in a digital way to physical puzzles or as a physical puzzles. Um, so basically, here they were connecting GeoGebra, where they were creating their logos or animals or whatever into physical puzzles using laser cutting. And the funniest part is when they had the opportunity to share these materials. So here you can see a bit more. But when they have the opportunity to share their ideas for the little ones, so the little ones were exploring their creations, uh, and they were really, really happy with this. So here you can see we took these materials in a mathematics festival here in Brazil, and they were really impressed with this lot of puzzle do they had available. So here you can see a little bit more about the math behind. So they had to use analytic geometry to complete this task. So with GeoGebra, they had to work with inequations or inequalities to paint out the different part of the puzzles. So basically, with high school students, they were using this task to develop their puzzle, and also they were sharing these puzzles with the little ones. So we had two different opportunities in using it, with the high school students by creating them, but also with the little ones by exploring the final material. Um, Here there is another material that I'm sharing with you, is a trigonometric circle. So we did in our lab as well. So they could move this rule, the transparent rule, to analyze the correct sinus or cosinus of the any angle. So to develop these materials, they were learning a lot about trigonometry. So, from my point of view, when we are doing in such way, from playing to making or to playing to learning, we have these different steps of opportunities to learn. Uh, so they are exploring the game or the puzzle initially, and then they have to create the puzzle and then test the puzzle they have created to the little ones or the other one. So this is kind of scheme that I have developed and I kept like that. So they combine math and technology to create their puzzles, but also they are developing their social skills when they are sharing their materials with the little ones. They get the feeling of being part of the learning of the others. So this is really significant for them. It's not only the logical skills, but also social skills. So here I brought just one example of another material that I'm developing with my student. It calls Rubik's Race. This material already exists commercially, but it's not that easy to get it in Brazil. It's also expensive. So we adapted it, uh, and we developed it in our laser in our maker lab. Um, so as you can assume, we have this pattern with 25 little squares, minus one here, and then we have to slide the squares in order to get this shuffled pattern. It's like this 15 puzzle, um, by Sam Lloyd, I guess, from Sam Lloyd, but with colors. And then we have the opportunity to discuss about combinatorics later. Um, so here we have our model where they have play two games at same time. So they have to scan the QR code to get the pattern, the goal pattern, and then they have to play together at same time. And who is getting first has to slide the the square here to just to be sure it's correct. Another game that's really meaningful to me is this one. I would say is the first one of this project, because I have tried out. when I was in Canada, I was interested in this time to model it in GeoGebra. But during this time in Canada, one of my colleagues there um, asked me if I was interested in renting out a 3D printing, a 3D printer. It was in 2017, and I got really surprised with this invitation, and I said yes, why not? So we offered to our students the opportunity to model the pieces of this game, and they got really engaged by this task. Uh, Actually, they were only two students because it was like an optional course, but it was really really meaningful because the original game uh, works with circle and square pieces. And in their cases, or in one of the students' case, he asked me if he was able to adapt one of the pieces for a triangular shape instead of square shape. And I said yes. It, it didn't matter for the game, the proposal of the game, but interesting was uh, he had to find the central point in an equilateral triangle. And that was not as easy as in the square. But he didn't give up. He didn't give up because he decided to use triangles. So I got this aha moment that he was insisting by his original idea because he basically shows it. Um, so we were discussing a bit about this challenge, let's say, and finally he got out. So um, another opportunity is working with AR, augmented reality. So in 2021, during the pandemic time, I developed a course, an online course for high school students where they had to choose uh, whatever they wanted from, let's say, a cooking topic, and they had to model it combining different surfaces or parametric surface. At the end, we were comparing the structure they had modeled it with the original one. So, and we got these one were made by myself, but these one were made by the students. So there were different nice ideas and solutions. So they had to explain, after all, for their colleagues how did they model it and how did they get inspired or something like that. Uh, but why we are doing this? So why we are working with laser cutting, augmented reality, um, or 3D printing? At the end, all of these techniques are useful for real life problems. So, what we consider, in fact, is the opportunity to prepare them to use their knowledge to solve real problems. So, here I'm sharing some examples. I'm really glad to share this one in the uh, left top corner because it's from yesterday. It's a really really recent one. A group of students of mine, they model it because their physical education teacher asked them if they were able to model it or to develop a ping pong racket. Uh, so they got an example, a digital example they were looking for on the internet, and finally they cut it out. So they made these rackets for the ping pong rackets. Something else, a colleague of mine modeled this tricycle just in order to don't throw away. Uh, this pedal was broken, so he repaired for his daughter at this time. I did a similar repairment with a suitcase and with a lamp, so we didn't throw away as well. So these kind of real life problems are really meaningful and good motivation for them. Another interesting problem that I got in my institution, they had for, I cannot remember properly the reason, but they had to estimate the volume of a water tank in our campus. So here in the back, you can see in the uh, right top corner, there is a cylinder water tank. uh, how they could estimate the volume if it was inaccessible, this water tank. So I told them they could use GeoGebra for this. Then I think I have to share another. Let us stop the sharing, and I'm changing the. I think now it's better. Can you see this cylinder in GeoGebra? So thank you. Basically, they had the opportunity to explore it here, either the radius and the height, and they can try to fit out with the real cylinder. So here they had some examples to test out. So they could basically move the radius and the height just to fit on the correct shape. And finally, since they got the meaning, they were trying out in the water tank. So based on this, they had the opportunity to estimate the right volume. After all, after this, we were comparing with the technical information, and it was really close. So coming back to our presentation, so this is the idea of developing these fitting or these skills in working with maker spaces and maker culture skills. So something else that is increasing a lot from the last 4 or 5, 6 years is considering inclusive education. So we are also developing inclusive materials here. Again, getting on mind math as a mean, not necessarily as an end. So they have to develop inclusive materials, but they have to use math in the process. We are not necessarily considering math as an end. So, switching a bit the topic, this is something more recent. Recent. Uh, I have worked the last 2 years in a paper based on tessellation. So here I brought an example from the 60s. You probably know this example. is a it's a pattern created by um, Penrose. Um, so with this pattern, we can cover the whole plane using these two different pieces. And important to say, we can cover the plane periodically. It means they are not repeating the pattern. So since this time, from the 60s to 70s, there was a question, an open question, if it was possible to cover the whole plane with one unique piece. So finally, we got the hat, or the Einstein one only piece, which covered the whole plane. Uh, it happened. This happened in March of 2023. So the Museum of Mathematics in New York launched um, a concourse. I'm not sure if the correct word, um, to to analyze different ideas of combining math and art, a competition to share different ideas to combine art and math. And this was an example of a created art and math design. You can check later. But here, we didn't participate in this competition, but some students of mine did this uh, construction using GeoGebra to develop their kind of piece. So this is step by step of the head piece. So basically, they start from a equilateral triangle. They mark the central point, and they were connecting this central point of the adjacent equilateral triangles, and they were reflecting some parts of the pieces, and finally they got the final hat piece here, or t-shirt, as you want. Okay, so why did they make it? Because we were interested in covering a window with this kind of pattern. So basically, we were using such pattern to create like a vitral to cover this window. So again, we were using digital uh, resource to convert in a physical material to explore the math behind. So here you can see another pattern that they presented some month later, I think 2 months later, because actually um the first draft, or the first model, the hat, actually it was not covering the whole plane with the same piece, since you have to flip it um, in the 3D space. So some mathematicians were unsatisfied, because they said, well, actually it's not exactly it's not properly one only piece, but we are considering two different phases. So maybe we shouldn't consider as a proper solution. So 2 months later, the same guys who created this pattern, they made the spectrum. They create the spectrum. So with this shape, um, they could cover the whole plane periodically with the same face. So there was no need to flip it uh, especially. So I have took this model for some events, and it's so nice to see how the students and the kids are really involved in try to solve it. So here I brought an example how to explore this kind of material. So in Matigon, there are some examples of a period tiling that we can explore it, and maybe we can cut it out later. Also in GeoGebra, there are some models, as I showed before. So there are different ways to explore these materials digitally. But if we have laser cutting, we can either convert this kind of pieces in physical material to let the kids play with it. Um, but a common question that I have, I used to listen is, and what about the schools has not such kind of equipment like laser cutting and 3D printing? Well, we can still work with maker culture perspective. So I have developed this task using only scissors and post-it. So I was teaching in this case the Escher technique. So how can we use such square tessellation and using translation and copying the same figure, we can cut it out and move the pieces that we are cutting out from whatever one of the sides and moving to the other side. Uh, so this is an interesting approach, even we do not have such equipment. Um, just to show you a little bit, this technique I have also developed in GeoGebra. So here you can see the all different steps. But here I did basically the same digitally. Then it means we can move the point and create our own pattern. So it doesn't matter if I have or not such kind of equipments, but we can do something really nice and playful for the kids like this. So we can consider this and adapt it to scissors and papers. So just to summarize the idea, which kind of developed skills we do have when we are working with such kind of approach. So something that I have identified is when we are playing with this, with such kind of games, I just shared some few of them, uh, but we can work with combinatorics or develop combinatorics reasoning, spatial reasoning, symmetry, patterns recognitions, coordinates, wherever. A lot of topics in math. By modeling, we can work with measuring, percentage, ratio or proportion, geometry in general sense, either rotation, parallel lines, inequality, and so on. By 3D printing or laser cutting, we can discuss about physical aspects like density, for example, ratio again, or proportion, volume, functions, for example, how long does it take to print out if I'm using such a size, and what happens if I'm double the size. Uh, this kind of conditions or functions aspect, it makes them think about different measures relationships, speeds, filament needs, time consuming, and so on. So, if someone is interested in the background, the theoretical background, I would recommend this paper. Um, is Technology Pedagogical Content Knowledge Exploring New Perspective. Um, so basically, we are discussing about the TPAC model, and we are bringing some perspective on using it in combination with this rapid technology who are coming out, which are coming out. Also, something to get on mind when we are working with such kind of 3D printing or laser cutting or maker labs is the different steps of working on it. So first of all, we have, if we follow this cycle, we have to explore and formulate the problem we are interested in. After all, after this, we have to generate and select ideas, to generate and select concepts, them, build the prototype or a prototype, testing and optimizing, and finally presenting to the others. So we have a kind of cycle, and then we can continue again, start again. This is the principle of PBL, project-based learning. So something that I didn't mention, but something important to consider is sharing decisions with students, uh, working with open tasks. It means they have no only one solution for this. Uh, Consider students' error and confidence, collaboration, options to choose the project they are working with, and students' protagonism. So these are some of the principles of working with project-based learning. Um, I didn't include in this presentation, but here I'm quickly showing you some other games that we have. So we have different games that we are reproducing it on our lab. So Abalone, getting in 10, so it's an operatoric game. Some puzzles, the calendar puzzles, other calendar puzzles, cubes, games, strategic games, abstract games, the Da Vinci Code, DAO, Genie Square. We have tested this game out with the students, with teachers, with researchers last year in Linz. Was so nice. X, Hive, it's a Brazilian game, La Boca, Logiphase that we have adapted from the original one. Uh, as far as I know, the inventor is from Budapest in Hungary. He made this triangle version, and then I have adapted for a square version, and I printed out. Here is the logic face. Otrio, it's a game that already exists commercially. Pentago, Quantic, Quarto, Rubik's Race, Sendazen, Set. We made a 3D version, Uluru, Inch, and so on. Okay. And here I have prepared quickly some examples from our lab. So here you can see some other opportunities that the students are coming to our lab and working on it. 2024. We are also sharing some participation on events that we are getting. So here for robotics, here is an affair in our city. Here is a integration with language. So the future teachers, language future teachers, were developing some games. So they had to use math to prepare. Some schools visiting us, workshops, materials. Teodolito, it was also in a workshop. So a lot of examples they could explore and to see. I think it's fine. And to finalize, I'd like to tell you a little bit about the current situation that we have here in Brazil. So we are participating in a national huge program. It calls the More Science in Schools program, and they are trying to reach 2,000 schools in the country. They have already 1,000 schools that they are implementing maker labs. So now, since we have the expertise, we have to support such schools. So, for example, here in our region, in the south of Brazil, we are responsible. I mean, our group, it's a intercamp project. So, for our region, which have uh, 8 million inhabitants, more or less, we are responsible for to cover 45 schools to implement such kind of maker spaces. So there is a big investment to support the schools in create such kind of maker labs. So this is really current situation that we have here in Brazil. It's a really huge project, and we are trying to reach nationally in 2,000 schools with maker spaces labs. So finally, to finalize, I'd like to share some reference that I have used for this presentation, especially 21 lessons for the 21st century from Yuval Harari, the lifelong kindergarten from Resnick, Mitchell Resnick, the Out of Our Minds from Ken Robinson, and Creative Intelligence from Bruce Nussbaum. Also, something important and meaningful to me is this video from Sugata Mitra. I would recommend Build a School in the Cloud. It's a TED Talk, and I would recommend you can follow it. Some last two slides. It should be come first actually, but I shared some repository for where you can get some models already done to print out. And then if you are interested in modeling, I would recommend for those who, for beginners, Tinkercad or GeoGebra. And here I have some final recommendation, some links. So basically you can follow our Instagram and also our lab, and follow such links to learn a bit more. So with this, I'm finalizing, and thank you too much for this opportunity.
Thank you very much, Diego, for this inspiring talk containing lots of practical examples and even, final ready to make print production things. On YouTube, I haven't seen any questions so far, so anyone following us on YouTube, you can, as long as you are logged in, type in the chat and ask questions. Our project partners are here in WebEx, and maybe they can, if they have, ask questions right away.
Can I ask Diego, can you send us these slides, if
Sure,
possible?
sure. I can share right now.
Because it was very good, but very fast, so I couldn't follow everything. And it would be nice to go again
Yeah,
through it.
sure.
Thanks.
May I share here in the chat?
Yeah, go ahead. Go ahead. Are we allowed to put these on
Yeah, sure.
in the YouTube comments as well?
Mm-hmm.
Great. Thank you very much. I guess this makes it easier for everyone also to click on your links you were referring to at the end, and everyone can also at the end relook. Well, in YouTube you can also stop the presentation if you want to look at something in detail.
Mm-hmm. Yeah, feel free to share whatever you want.
Thank you very much. Any other questions here from the project partners? No questions, and everyone was so clear and so well explained that nothing remains questionable. Thank you very much again, Diego, for your time and for your inspiring ideas. I hope we will meet again soon in person. It was a pleasure working with you. Thank you very much, and have a nice day.
Thank you. Thank you for all, and have a nice day. And I hope you have success with this project.
Okay, thank you.
Thank you. Thank you. Bye-bye.
Bye.
Bye.
Okay, so I stopped the YouTube live.